We're practically drowning in information. Every single year, millions of scientific papers get published, creating this just massive ocean of text. But what if I told you that beneath that surface, there's a hidden world, an invisible network of influence that connects every single one of those ideas? Well, today we're going on an expedition to map that world. And that brings us right to the heart of the problem, doesn't it? In this absolute storm of information, how do we find the signal in the noise? How can we possibly tell which ideas are genuinely shaping our future and which ones are just, well, echoes in the chamber? That is the big question we're tackling today. All right, first things first, to even begin, we have to totally shift our perspective. We have to stop thinking of science as some dusty, static library full of old documents. Instead, we need to see it for what it actually is, a living, breathing ecosystem where ideas connect, compete, and evolve, all in real time. And hey, this isn't just some poetic metaphor. There's a whole formal discipline dedicated to this exact idea. It's called Scientometrics. You can think of it as the science of science itself. It uses hard data, citations specifically, to turn that abstract ecosystem of ideas into something we can actually measure, analyze, and, you guessed it, map. So if we're going to map this world, we're going to need some tools, right? We need ways to measure the weight and the importance of all the different points on our map. Let's take a look at two of the most common ones you'll hear about. Okay, so let's break down these two key metrics. On one side, you've got the H-index. Now, this is a score for an individual researcher. It's a clever way to measure their impact because it's not just about how many papers they've published, it's about how many of those papers have actually been cited by other scientists. Then on the other side, you have the impact factor. This is totally different. It's a score for a journal, not a person. It basically tells you the average number of citations articles in that journal get. So really, the H-index is about a person's sustained influence, while the impact factor is more about the perceived prestige of the publication itself. All right, we've got our tools. Now it's time to actually start building our map. And just like any good map, ours needs landmarks. Those major points of interest that everything else is kind of built around. In our world of ideas, these landmarks are specific, truly game-changing papers. And it all boils down to this one fundamental building block. Our entire sprawling map begins with just one point, a single idea published in a single paper at a single moment in time. But let's be real, not all papers are created equal. Some are just another little dot on the map, but others are true landmarks. We call these key papers. These are the publications that just fundamentally change the entire conversation. They're the ones that everyone who comes after has to respond to, creating the conceptual backbone for a whole field of study. Now, having landmarks is a great start, but a map with a bunch of dots isn't very useful without the roads connecting them. And it's in these connections that we find the true structure of knowledge. This is how we go from just a collection of points to a powerful interconnected network. The way this works is actually beautifully simple. When a new paper references an older one, it creates a link, a citation. It's an explicit hat tip to its influences, drawing a clear line from a new idea right back to its intellectual ancestor. And believe it or not, there's a whole field of mathematics for this stuff called graph theory. It gives us the precise language we need to build our map. The papers become what are called nodes, or points, and the citations become edges, which are the lines connecting them. And that's huge, because suddenly we can use powerful computer algorithms to analyze the shape, the structure, and the flow of our entire map of knowledge. Okay, here's the real aha moment. Think about how Google's search engine works. A link to your website from, say, the New York Times is worth way more than a link from some random blog, right? Well, it's the exact same principle here. A citation from one of those key papers, our landmarks, is like a massive vote of confidence. It carries so much more weight and tells you that an idea is truly important. So what happens when we scale this all the way up? When we plot millions of these points and all their weighted connections? Something incredible starts to happen. A hidden landscape begins to emerge from the data, revealing the true underlying structure of an entire scientific field. So how do you actually make one of these maps? Well, it's a pretty clear systematic process. You start by gathering massive amounts of citation data from huge databases. Then you use algorithms to find clusters of related papers and really influential connections. After that, you visualize the whole complex network. And finally, you get to interpret the map to see how a field is organized and, more importantly, where it might be going next. And what do we usually find right at the heart of this landscape? Something called a network core. The best way to think about it is like the capital city of an intellectual domain. This is the most densely packed, interconnected area on the whole map. It's where the most important conversations are happening, where the foundational ideas live, and it's really the center that defines the entire field. So, when it's all said and done, the final result of all this work is what we call an influence map. And it is so much more than just a pretty picture. It's a dynamic chart of how ideas are born, how they travel across a field, and who the real intellectual power brokers actually are. But now that we've built this incredibly powerful tool, we have to ask ourselves a final, really critical question. One that kind of challenges the very foundation of the map we just made. Are we really charting the flow of pure knowledge, or are we just mapping reputation? This leads us to this really radical concept called zero-based thinking. It's a thought experiment. It asks us to just ignore all the established metrics for a second, the impact factors, the famous university names, all the historical prestige, and just start from scratch. It forces us to ask, from a completely blank slate, which ideas genuinely influenced others, regardless of who wrote them or where they were published. So I'll leave you with this question to chew on. If we could actually truly separate an idea's intellectual merit from all the inherited reputation that comes with it, what would our map of science look like? Would the landmarks still be in the same place? Would the capital city still be the capital? Or might we discover an entirely new world of ideas, one that's been hidden just beneath the surface all this time?